300 ppm historically, and then it goes above about like 2 degrees C above the average temperature of Earth. And then this is a current trend. Current level of CO2 concentration is 388 ppm. Every year I present, this number goes up. I'm kind of like I started a couple of years ago, same kind of presentation, and it was like 385 around that number. So every year it goes up. And then past 10 years, annual growth rate is a 1.91 ppm per year increase. And then scientists says by the year of 2035, it may go up to 450 ppm. And then the scientists call this is like a tipping point. Something will start happening in a, climate or weather, but it's already started happening. So like at 450 ppm, I don't know what's going to happen further. And then also the temperature, Earth's average temperature might go up to like 2 degrees centigrade more with the 450 ppm. And then obviously looking at the sea level change, it's kind of correlate with the temperature difference, also the CO2 concentration increase. But going back to the prehistoric, the last time we had we experienced 2 degree increase is 125,000 years ago. And then at that time, sea level was 4 to 6 meters higher. And it was less than 300 ppm. We already 388 ppm. And then it's going to be 450 around 2035. Then what's going to happen to the sea level then? So what will happen to our beach? Obviously, there is no beach here, but in the North Carolina, well, it might be in the North Carolina. This is a shoreline from North Carolina, South Carolina to Georgia. And the red area is the area which will be affected by the sea level rise. So a lot of a town will be major town like Charleston, Savannah. This town could be the underwater. And then this is analysis from the 2030 Challenge website. So these are major beach in North Carolina. And then majority of the town will be underwater with just 2 meter sea level rise. And then, so what is causing this? And then the blue portion, 65%, it says increased activity of a global economy. So basically it's based on expansion of my economy. And then the red area, it's a deterioration of a carbon intensity of economy, which means the economy getting more carbon intensive. And then 18%, it's decreased efficiency of a natural sink. That means, let's see, so naturally CO2 goes to atmosphere, almost like half of CO2 go to atmosphere. And then the 30% goes to land, which is going to the soil, or tree absorbs CO2, or other plants absorb CO2. And then 25% goes to ocean. Ocean absorbs CO2. But eventually, it's going to happen more and more CO2 just remain in the atmosphere, right? That's a cause of global warming. And then we see less tree every year, a lot of deforestation going on. So the thing in the land area is decreasing. And then the capacity of ocean to absorb the CO2 is decreasing because it has capacity. And then ocean going to be more acidic in future. So IPCC says like it's extremely likely this is caused by human. When they say extremely likely, it's like a 95% of probability is by the human cause. And then this is another aspect, looking at the CO2 concentration trend, temperature trend. Also, it's really correlated with the coal use trend. So definitely coal is one of the main source of CO2, which means our electricity, majority of our electricity comes from coal as well. And then looking into industries. the building sector uses almost 50%, half of our energy. So as an architect, or if you're a builder, we have to deal with it in our field. And then the rest of half is divided into the transportation industry. These sectors becoming more efficient. Traditionally, they, like an industry, they need to be really efficient in order to make a profit. So naturally, it goes efficient way. And the transportation, you are seeing hybrid, electric cars. So it's going that the curve of going towards the efficiency is really steep compared to the building. So we have to really deal with the building. So this is kind of our goal, the building sector shrinking, going towards net zero. And then also pi itself, which is energy use. We want to shrink this down as well. So as an architect, we set the goal, Architecture 2030 or 2030 challenge. So immediately, it was 5 years ago set. So like a 50% decrease of energy use compared to national average. And then by year of 2010, which is this year, it goes down to 60%. And every 5 years, it goes, efficiency goes up. And then by the year of 2030, we are hoping towards the carbon neutral or net zero, you call. But it's impossible to every building on the Earth to be a net zero. So our target is going down to the 1990 level by the year of 2030 by introducing the more net zero building. So going to this building, so this building is trying to achieve that 2030 goal right now with use of available technology.